Good morning to all. I am DR.S.THAYALNAYAKI, Assistant Professor of Computer Science, A.D.M. College for Women, Autonomous, NAGAPATTINam. Data mining and data warehousing. Now we see about the data mining functionalities. Data mining is a technical methodology to detect information from huge data sets. Main objective of data mining is to identify patterns, trends or rules that explain data behavior contextually. The data mining method uses mathematical analysis to reason patterns and trends which were not possible through the old methods of data exploration. Data mining is a handy and extremely convenient methodology when it comes to dealing with huge volumes of data. Here see some data mining functionalities that are measured to predict the type of patterns in data sets. Here list some popular functionalities of data mining such as data characterization, data discrimination, mining frequent patterns, associations and correlations, and next classification, association analysis, cluster analysis, prediction, outlier analysis, evaluation analysis. Here see the below figure for various functionalities of data mining. Data mining functionalities. Data mining is the process of collecting information from massive data sets, detecting patterns and uncovering connections. Functionalities in data mining are used to define the kind of patterns that data scientists will discover in data mining activities. Data mining has a vast application in big data to predict and characterize data. The function is to find trends in data science. Generally, data mining is categorized as data mining operations are divided into two types, which are descriptive and predictive. Descriptive mining tasks describe the general characteristics of the database data. Predictive mining tasks produce predictions by making inferences on current data. So functionalities are chosen according to the data mining process. First of all, we see about the descriptive data mining. Similarities and patterns in data may be discovered using descriptive data mining. Descriptive data mining may also be used to isolate interesting groupings within the supplied data. This kind of mining focuses on transforming raw data into information that can be used in reports and analysis. It provides certain knowledge about the data, for instance, count average. It gives information about what is happening inside the data without any previous idea. It exhibits the common features in the data. In simple words, you get to know the general properties of the data present in the database. Predictive data mining. It is not the present behavior what is being mined for, but rather provide predictions about the future. It takes advantages of target prediction capabilities gained via supervised learning. Classification, time series analysis and regression are the subset of data mining techniques that fall under this domain. This helps the developers in understanding the characteristics that are not explicitly available. For instance, the prediction of business analysis in the next quarter with the performance of the previous quarters. In general, the predictive analysis predicts or infers the characteristics with the previously available data. Next, below all are the data mining functionalities with examples, so that you have an in-depth understanding of how these functionalities are used in the real world to work with data. First of all, we see about the class concept description, that is characterization and discrimination is the class concept description. Data is associated with classes or concepts, so they can be correlated with results. Data class concept description can be explained for data mining functionalities with examples. An example of data mining functionality in the class concept description can be explained by, for example, a new iPhone model which is related in the variants to attend the targeted customers based on the requirements like Pro, Max and Plus. Next, a class or concept implies there is a data set or set of functions that define the class or a concept. A class can be category of items on a shop floor, and concept could be the abstract idea on which data may be categorized, like product to be put on correlations or put on clearance sales and non-sale products. There are two concepts here, one that helps in grouping and the other that helps in differentiating. First, data characterization. When you summarize the general features of the idea, it is called data characterization. It produces the characteristic rules for the target class like our iPhone buyers. We can collect the we can collect the data using simple SQL queries and perform OLAP functions to generalize the data. Attribute oriented induction technique is also used to generalize or characterize the data with minimal user interaction. The generalized data is presented in various forms like tables, pie charts, line charts, bar charts and graphs. The multidimensional relationship between the data is presented in a rule called characteristics rules of the target class. Next, characterization involves the summarization of general features of the data resulting in specific rules that define a target class. A data analysis technique called attribute oriented induction is employed on the data set for achieving characterization. Next one is data discrimination. Data discrimination is one of the functionalities of data mining. It compares the data between the two classes. Generally, it maps the target class with a predefined group or class. It compares and contrasts the characteristics of the class with the predefined class using a set of rules called discriminant rules. The methods used in the data discrimination is similar to data characterization. So, discrimination is used to separate distinct sets of data based on the disparity of the attribute values. It is a comparison of features of a class with the features of one or more contrasting classes. Next one is mining frequent patterns, associations and correlations. Discovering pattern from huge set of data is primary task of the data mining. The most frequent patterns are those that most common in data. Different kinds of frequency patterns that are found within the data are common item sets, frequent subset structures and frequent subsequence. First of all, common item sets means this term refers to a set of items commonly encountered together, for example, car and engine. Frequent substructure means different kinds of data structures that may be integrated together with item set or subsets like graph and trees. And another last one is frequent subsequence. A pattern that is regular, for example, like purchasing a mobile and then the purchase of a cover. These are all the frequent patterns. Next one is correlation analysis. Correlation is a mathematical method to determine how closely two characteristics are connected to one another. It determines the degree to which two continuous variables that are numerically measured are connected. Correlation is a mathematical technique for determining whether and how strongly two attributes are related to one another. It determines how well two numerically measured continuous variables are linked, example, height and weight. Next, correlation analysis is used in researchers can use this type of analysis to see if there are any possible coordinations between the variable in their study. For example, people with good height can be in the heavier. It refers to the various types of data structures such as trees and graphs that can be combined with an item set or subsequence. Next one is classification. As the name suggests, classification is the technique to categorize elements in a collection basis that predefined functionalities and properties. In classification, the model can classify new instances whose classification is unknown. These particular instances that are used to create the model are called training data. Such a mechanism of classification uses methods like if-then, decision trees, neural networks or even a set of classification rules. These methods can be retrieved to identify future data. So, classification is probably one of the most important data mining functionalities. It uses data models to predict the tracks in data. For example, the spending chart our internet banking or mobile applications based on our spread platform. This is sometimes used to define our risk of getting a new loan. It uses methods like if-then, decision trees, mathematical formulae or neural network to predict or analyze a model. It uses training data to produce new instance to compare with the one existing. Classification is a data mining technique that categorizes items in a classification based on some predefined properties. A training set containing the items whose properties are known is used to train the system to predict the category of items from an unknown collection of items. It uses methods like if-then, decision trees or neural networks to predict a class or essentially classify a collection of items. First of all, here we see one of the example for if-then. The if class of an if-then rule is referred to as the rule antecedent or precondition. The then portion of the if-then rule is known as the rule of consequent. The antecedent portion of the condition includes one or more attributes test which are logically ANDed together. The antecedent and the consequent are used together to make a binary tree or false decision. Next one is decision tree. Classification models may be created with the use of decision tree mining, a data mining approach. It contrasts tree-like models for classifying data. It is utilized in the development of data models for forming inferences about classes of objects or numerical values. Next one is neural network. By efficiently transforming unstructured data into usable insights, neural networks are a common tool for successful data mining. Using this method, companies may separate through maintain of data in search of insights about the clients. Here we see the example. Classify a large set of items in the store based on 3 kinds of responses to a sales campaign: good response, mild response and no response. Derive a model for each of the 3 classes based on the descriptive feature of the item, such as price, brand, place mode, type and category. Here we see the example if-then rules. If age, youth and income high means class A category. If age, youth means the income low, then it belongs to the class B category. If middle-aged persons in age, then under class C category. If age is senior, that means it comes under the class C category. Here see the example, if-then rules. Another one is a decision tree example. In this, predict the amount revenue that each item will generate during an upcoming sales of all electronics based on the previous sales data. Prediction. Prediction means in data mining functionality, it finds the missing numeric values in the data. It uses regression analysis to find the unavailable data. If the class label is missing, then the prediction is done using classification. Prediction is popular because of its importance in business intelligence. In data mining, there are primarily 2 types of predictions: numeric predictions and class predictions. Numeric predictions are made by creating a linear regression model that is based on historical data. Prediction of numeric values helps business ramp up for a future event that might impact business in a positive or a negative way. Class predictions are used to fill in missing class information for products using a training data set where the class for products is known. There are 2 ways one can predict data. One is predict the unavailable or missing data using prediction analysis, predicting the class label using the previously built class model. It is a forecasting technique that allows us to find value deep into the future. We need to have a huge data set of past value to predict future trends. Next one is cluster analysis. The cluster analysis process is similar to that of a classification. In cluster analysis, similar types of data are grouped and our only difference is that the class label is unknown. Clustering algorithms divide the data basis similarities and the grouped data are similar to each other more than the other data in other groups. Cluster analysis is used in machine learning, deep learning, image processing, pattern recognition and NLP, etc. Here see one of the example. Let us understand this with an example. Suppose we are market manager and we have a new tempting product to sell. We are sure that the product would bring enormous profit as long as it is sold to be the right people. So how can we tell who is the best suited for the product from our company's huge customer base? So in customer analysis, unsupervised classification is called cluster analysis. It is similar to the classification functionality of data mining where the data are grouped. Unlike classification, in cluster analysis, the class label is unknown. Data are grouped based on clustering algorithm. The objects that are similarly grouped under one category, one cluster, there will be a huge difference between one cluster and the other. Grouping is done to maximizing the intra-class similarity and minimizing the intra-class similarity. So, clustering is applied in many fields like machine learning, already we told that machine learning, image processing, pattern recognition and bioinformatics, etc. Below see sample for clustering algorithm and like a little bit about. K means clustering algorithm. Here we see about the one example. The goal of the K means clustering is to divide the data into K groups so that the members of each cluster have similar characteristics while those of other groups are more dissimilar. When computing the similarity of two spots, distance is the most important factor. This technique operates on the assumptions that data points inside a cluster should have a little variation as possible. Why is clustering used in data mining? Clustering analysis has been an evolving problem in data mining due to its variety of applications. The advent of various data clustering tools in the last few years and their comprehensive use in a broad range of applications including image processing, computational biology, mobile communication, medicine and economics and contribute to the popularity of these algorithms. So, the main issue of with the data clustering algorithms is that it can be standardized. The advanced algorithm may give the best results with one type of data set, but it may fail or perform poorly with other kinds of data. So, although many efforts have been made to standardize the algorithms that can perform well in all situations, no significant achievement has been achieved so far. So, many clustering tools have been proposed so far. However, each algorithm has its advantage or disadvantage and cannot work on all real situations. Next, outlier analysis. Outlier analysis is the process of identifying outliers or abnormal observations in a data set, also known as outlier detection. It is an important step in data analysis as it removes erroneous in inaccurate observations which might otherwise skew conclusions. If we are unable to group any data in any class, we use the outlier analysis technique. Outlier analysis helps to learn about data quality. Outlier means data abnormality in most cases. Most outliers in your data sets lower the data quality. You cannot identify the data patterns or derive any conclusions from data sets with a big number of outliers. The outlier analysis process helps in checking if there is any data that can be used to analyze after some cleanup. Nevertheless, it is still important to keep a track of unusual data and activities so that any anomalies can be detected beforehand and any business impact can be detected in advance. When data that can be grouped in any of the class appears, we use outlier analysis. There will be occurrences of data that will have different attributes to any of the other class or general models. These outstanding data are called outliers. They are usually considered noise or exceptions, and the analysis of these outliers is called outlier mining. This can be considered as one of the other functionalities of data mining. These outliers may be valuable associations in many applications. Although they are usually discarded as noise, they are also called exceptions or surprises and is significant in identifying them. The outliers are identified using statistical tests that find the probability. Other names for outliers are deviants, abnormalities, discarded and anomalies. Okay, what happens in outlier analysis? Outlier analysis is a type of data mining task known as outlier mining. Data scientists may use it to detect fraud in a variety of situations, including unexpected credit card or telecommunication usage or healthcare analysis to detect old responses to medical treatments and marketing to discover client purchasing habits. So, data science professionals can find outliers in a variety of methods. All of these strategies use various ways to discover values that are out of the ordinary in contrast to the rest of the data set. Outlier analysis is important to understand the quality of data. If there are too many outliers, you cannot trust the data or draw patterns out of it. An outlier analysis of the data that cannot be grouped into any classes by the algorithms is pulled up. An outlier analysis tries to determine if there is something out of turn in the data, and does it indicate a situation that a business needs to take account of and take measures to mitigate it. In most cases, outliers are data abnormalities. Still, it is important to take note of each so unusual activities or events that trigger a business impact can be detected well in advance. Next one is evaluation analysis. Evaluation analysis refers to the study of data sets that may have been through a phase of transformation or change. Evaluation analysis models capture evolutionary trends in data, which further contributes to data characterization, classification or discrimination and clustering for multivariate time series. Evaluation analysis refers to the description and model regularities or trends for objects whose behavior changes over time. So, evaluation analysis pertains to study of data sets that undergo change over a time period. This model are designed to capture evolutionary trends in data, helping in characterizing, classifying, clustering or discrimination of time related data. Thank you.